Hi everyone, Krishna this side. In this video, I'll be covering this 3403 problem from the LeetCode, the find the lexicographically largest string from the box one. So let us go through the problem statement first, then I'll explain you the logic, then we'll write down the solution as well. So you are given a string word and integer nums friends. Alice is organizing a game for her these many friends like she is having, and there are multiple rounds in the game where in each round word is split into num friends non-empty strings such that no previous round has exact same split. All the split words are put into a box. Find the lexicographically largest string from the box after all the rounds are finished. So first thing is like we need to understand what is lexicographically largest string, right? So let us suppose if we have these two strings, Y, B, like this one, and then there is another G. So out of these two string, which is the lexicographically largest string? Obviously it is Z. So how it is, right? So let us suppose we'll discuss with another example DBC, and there is another one is okay. DB. So out of these two, right? So which is the largest one? Right now here, how the things works is like we first check with the first character. Both the characters are same. If both the characters are same, we basically compares with the second characters. If both the characters are again same, we try to check with the third character. So this is like how lexicographically largest string order we figure out. Okay. At any point in time, if a character is having higher precedence than the comparing character, obviously whatever the character that got highest precedence, that particular string is going to be the largest lexicographically string. Okay, so that is something what we need to understand. So in this same example above, we compare Y with the Z, and here Z is having highest order, so obviously this G is going to be the answer. Doesn't matter like what is the length of the string or how many characters are there in the particular string. Okay, so by considering this fact, so we will first let us look into this first example, and we'll try to figure out like how we can approach to this particular problem. Okay, so we have given this word and number of friends. So in this one, two friends are there, right? So we have to put one mark in such a way that we if we split the string, whatever the strings, all the possible different possibles that we got, out of which the maximum string that we got, that is something what we need to return. So the first mark we can put is right after the D. So here D is one string, another string is like BCA, right? Because two friends, so one string got into this friend and another got this BCA to another friend. Okay, another mark what where we can put right after the B. So DB is one possibility, C is another possibility. Last one is like DBC and A. So these are different possible combinations that we can have, right? So apart from this, there are no possibilities, right? So yes, out of these all the strings, which is the largest lexicography string, which is the having the highest order. So obviously it is DBC, right? Because DB, if we compare, DBC is the largest one because C is extra character that we have comparing with this particular DB, and all the others are like having less I mean less order than comparing with this DBC, right? So DBC is something what we need to return. So if we have four friends, if we look into the second example, we can put first here, second here, third here, and last is going to be the at end. Okay, so we split this G in four ways. Okay, and G is obviously the maximum that answer we can get, so G is something what we need to return. So if there is only a single friend that we have, then obviously we can put the split at the end only, because the entire string is something what we need to return, right? There are no extra friends, right? Like only one single friend is there, so obviously the split is going to be at the end, and that is something what we need to return. So that way we can return the entire string. So if there is only one friend, the entire string is something what we need to return. That is something what other thing that we need to remember here. Okay, now these are there like how we can approach to this particular problem, right? So see, uh any from this particular string, what is the maximum string that we can get, which could be a possible answer, right? So maximum string, to figure out the maximum string that we can get, which is having the maximum length, that string if we want to figure out, like we can have this m, let us consider the m, and what we can try it is this word dot length. Let us suppose if it is 4, the word dot length is 4, right, from this particular example, and number of friends plus 1. If we do this, we will get the maximum length of the string that we can achieve from this particular word. Okay, what I'm trying to say is, let us suppose 4 is the length that we have, two friends that we have, plus 1. If we do here, we get the 3. So from this particular string, the possibility of the length which is going to be the answer, that is the maximum length that we can achieve from this particular string, is 3. Okay, we cannot consider 4 length string, and we can put a split after the fourth length of the string, and we split that string into the two friends. That is not going to be possible, right? So let us suppose two friends are there, right? And I want to get a 4 length string. So the if I consider for first friend the 4 length string and I try to put a mark right after a, the first friend will get TBCA, but for the second friend it is empty string, right? Obviously there is nothing, so it is going to be the empty string. So is it going to be the answer that are we even following the rules? No, right? Because it should be non-empty strings for all the friends. So we cannot achieve 4 length string. But what if we can put a split right after C? So the first friend will get DBC, that is having the length 3, and the second friend will get A. Okay, so this is possibility, right? Because we can split the string into two halves. The first will get length of 3 and the second will get A. Or we can put a mark right over here after the D. So first will get D and second will get BCA. Okay, so the max length that we can achieve for a particular friend is going to be 3. So that is something what I tried figuring right out over here. So the max length that we can get is 3. Okay, so more, not more than this. Okay, so we cannot achieve a string which is having length more than the 3. Okay, this is one thing that we got. Okay, now based on this we can, what we can do is like we can use two pointers approach, right? So we will keep on checking what is the maximum length that we can. Based on this we keep on checking three lengths character, and we keep on checking that if it is the largest lexicographical string comparing with the previous string whatever we got, and we keep on updating the string. Okay, this is like based on with the help of two pointers approach. Now we can try to solve this one, but there is another thing, right? So we know that like whatever the maximum character that we have from the string, even if the character appeared only once, and the other strings that are there from the string which is having the maximum length, still the single character is actually the largest lexicographically answer that we can achieve, right? That is another thing that we have. So what we will do is instead of keep on looking these three characters from the string, we will figure out which is the character that is having the largest precedence. Okay, so from this particular word D is actually having the largest precedence, right? So what we will do is like we will keep on checking in the string where the D actually appeared, and based on that we will check the maximum length from that particular one and we will compare it one. Okay, what I'm trying to say is let us suppose we have this YYB G and we have 2 is what we have the friends. So from here the maximum length that we can achieve is 3. This is the first possibility. The other possibility is Y and then BB is Z, and the third possibility is YB BZ, and then the third possibility, is there any possibility? No, right? So three possibilities that we can achieve. From these three possibilities we can see that only this G is the what having the largest one, and this is the answer that we need to return. So the minimum that we can achieve is like from all this one, what we found out is like wherever the G character appeared, that is the maximum answer that we can get from there. Okay. So the maximum length that we can get is either one or whatever the length that we can achieve, that this particular length that we have 1 to 3, between this whatever the maximum characters that we got from the I mean maximum lexicographically ordered string that we got, that is the answer that we can get. So what we will do is first we let me write down the code and then I'll explain you the logic as well again. So we will check if numFriends equals 1. If that is the case we simply return the word, because we cannot put any split in between of the string, and it will be split into two half and we have only one single friend, right? So we basically need to return the same word that we have. Okay, that is the first thing that we do. Now the second is like let's get the words length. Okay, I get that. Now let's get the m. M is something what I already discussed, like why we need the m. Word dot length minus numFriends plus 1. Okay, now we got this one. Now this next thing is like let's get the character which is having the highest precedence. Okay, from this particular string. So what I'll do is I'll put this word dot char at 0, 0th character I put here, and we loop from 1 to word dot length, that is like n I plus plus. We keep on checking that which character is the having largest value. So ch equals math dot max ch and word dot char at I. Okay, that's it. Like we get the maximum character that actually we have from the string. So it doesn't matter from the string we have z is what we have the maximum the character that that is having the highest precedence compared with all the other characters. That is something what we will figure out so that we can avoid all the different combination that we can get. Now we will basically check where that character actually appeared for int I equals 0, I less than n. Again we will loop which keep on checking if ch equals word dot char at I. If that is the case, I mean we found out that the character's location now. So if the character is there now, here the thing is like we will be having either this length 3 or 1 to 3. In between this, whatever the length that we get, that is going to be the answer with this particular character. Okay, if the character actually appeared right over here, z is something what appeared here as well as here. So from this one, what are the different possibilities? These are the different possibilities, right? Okay, these are the different possibilities. Now from here, this is going to be the highest precedence, right? So what we will do is first we check at first index this character we found. Okay, now we will check from 1 to 3 if it is falling into that one. Okay, if it is less than the if it is equals to 3, I mean that is something what we need to figure out. If that is the length that we are getting, so definitely that is going to be the answer that we have. And we keep on checking in the future also if that character we found it and that character's length is actually having a higher lexicographically order, then we will update the answer. Okay, so first thing is like I'll get the start is something what we have I from that current character. Let me get the end equals if this I plus this m, if it is actually less than equals to n, that means our length, like let us suppose we are at first index, first 1 plus this m is actually what we got, it is 3, right? 1 plus 3, it is actually 4, it is less than or equals to 4, right? In that case I can basically consider this particular string, okay, this particular string's length, or else we can go till n. Okay, so why I'm saying is like either that entire length or till last index of that character. That's something what we need to figure out. Like I'll explain you again. So let me get this substring from this one. Yes, should be substring. Okay, yes, should be capital from the word dot substring of start is I, end is something what we figure out. So this end is actually 1 to 3 max, whatever the maximum that we have, that is something what we are actually holding. So I plus m, if it is less than equals to n, that means the 3 is actually what we can get it from this particular one. Okay, if not, that means like z is actually appearing in the last precedence, like here somewhere it is appearing which is having less than length of 3. So we will go till the last index. Okay, that's why I actually consider here if it is less than or equals to n, I will consider that till that entire word substring whatever we have that I want to consider, or else we will go till the end and we get the substring. Once we get the substring, what we will do is we'll check if answer dot compare to this substring. If it is less than 0, that means we need to update the answer. Okay, because this new substring is having highest lexicographically order compared with the previous answer. We updated it, and now this will keep on checking, and it keeps on updating the answer. At the end, what we have to do is we need to return the answer. Did I create the answer? No, right? Let us create a string answer, and yeah, that's all. Like we get the answer. Now if I take you through example, let us have this example with us. We have, let us suppose we have a y, let's stick with y, z, b, c, bx, g, y, and then what I'll do is, okay, this is like 4 characters the string that we have, and we have this n equals 2. Okay, number of friends. So how, what is this m actually? M is actually equals this m, if we figure out, it is actually 3. So 3 length of string is what we can get the maximum answer that we can achieve from there. And what else? N is actually 4. Okay. And now we figure out that the character which is the maximum lexicographical order, so the character is Z. So ch actually equals Z. So all these values we figure out. Now we will start from this loop, and we check wherever the character lies. Now at 0th location we found the character, so what we will do is we figure out the end. The end equals, we check that 0, that is 0th location, plus m is actually 3. 0 plus 3 basically equals 3, which is less than 4, less than or equals to 4, right? Since this substring basically actually this is exclusive, right? So this is inclusive but this is exclusive. So at the end here we can go till the end of the string. So if it is not if it is inclusive, then I would have considered less than n. Okay, but based on this substring, we are actually going till all the last length of the string. Okay. Now this is actually less than or equals to 3, so we get the substring from 0 to end of the string. So this end, whatever the value that we figure out, so it is actually 3. From 0 to 3, what is the substring that we have? This is the substring, right? Like zbz. Zbz is the string that we got. So now this gbz is something what less than or equals to, if we compare, obviously the answer is by default it is empty, so we put this into the answer. So now the answer is actually gbz. Okay, this is done. Now we again check where is the g actually appearing. If we look into this particular example, now we got at second index we got z again. Okay, now we check that we figure out end. So here I actually at second index, so end equals 2 plus, now 3 is something what we need to add, because that is like, and this is basically, is it even possible like 5 is less than or equals to 4? No, right? So we will, what we will consider is its length is actually lies from 2 to end of the string. Okay, this is the substring that we need to get, because this is basically going beyond n, right? 5 is something what going beyond the end, so 2 to 4 is something what the range that we need to consider. So what is the substring that we got? Substring is new substring is actually z and y. Okay, gy is something what the substring, new substring we found. So the previous answer was zbz, and new is gy. If we compare them lexicographically, which is the higher precedence, gy is obviously right. So we will update the answer, because here doesn't matter the length. G and z we compare, both are equal, so we compare the second characters b and y. So here y is something what the having the highest precedence, right? So gy is the new answer that we got, so we will put it into the answer. And we check that if any at any point in time, if we have z again, it is not there, right? So we simply return that answer. Okay, so if we consider gy, we can put from this particular example, right? So b, zb and gy, these are the two strings out of which gy is the answer that we are getting it. Okay, this based on the split, if we put right over here, this is the answer that we can get, and that is something what we are returning. So let me run this code. Now talking about the, let me run this code first. Okay, expected line number 14 string answer equals, let us run this code. Okay, line number numFriends. Okay, word dot length. Yeah, sorry for this thing. I don't think there are any more issues. Okay, all cases are getting as settled. Let us submit this code. And talking about the time complexity, so it is actually going to be, in the worst case, n cross m, because if the z character, let us suppose if it is appeared at all the different locations, so we keep on going at those locations, and we keep on getting the length, and we keep on trying to figure out which is the possibility maximum answer. But in the best case, like we are actually omitting all the different possibilities that we can get it, right? So if m is actually 1 at once only, if character is actually appeared, so in the best case it is like obviously big O of n. Okay, so that's all from this particular exam, this code, and I hope you guys got some learning. Thank you for watching this video. Bye bye.